Well, thank you, first of all, for your invitation and for your organization, Jean-Marc, Etienne, and all the friends from the French Mars Society. So my name is Charles Frankel. I'm planetary geologist by trade and taught topics like that at the universities, but I'm mostly a popularizer, science popularizer. And so my talk has nothing research-oriented in it. Some people are going to find it, we know all this. But maybe for others, it will be a refresher course on where we stand now with life on Mars. First of all, this painting, my mother painted for me on my 21st birthday in 1976, Viking, the first landing on Mars. And so she made this from the photos. By the way, obviously there is life on Mars. We don't even have to go through a talk like this because if you haven't noticed yet, there you have it. Of course, you had to look. And that is one of the first lessons that obviously Carl Sagan, who was, and I'll talk like him, Carl Sagan, who was at the very beginning of all of this, would have reflections such as turn on cameras at night, you never know, life could be large and come out only at night. And he was trying to get us to think out of the box. So the Viking missions, two Viking missions, 1976 landings in two very interesting places, Chryse to the left, which is where the outflow channels come out, and then Utopia Planitia up north where supposedly there was more water ice in the soil. And the experiments there, if you remember, was to dig soil and put it in a bunch of experiments. And this gives you, it all pretty much held in a shoebox almost, or a small suitcase. You had a gas chromatograph linked to a mass spectrometer that allows you to measure, guess what molecules are being fed, either from the air, to get the composition of the air, or from the soil. And here is the three interesting experiments that looked at the soil to see if there was life in it. So many of you know the data, but just to go through three different possibilities, three experiments. One where you just basically put some nutrients into the soil and see if there was any gas exchange. Nutrients meaning amino acids and the such, basically food, carbon, which any carbon-based life process would love for lunch. Chicken soup, as we say. So interestingly, this gave off a little bit of oxygen when it was moistened with the nutrients, and that kind of was a surprise. This guy didn't give much. Pyrolytic release was, if there is life, maybe it's photosynthetic. And if you give it carbon dioxide, maybe it's going to release oxygen. So try that. But yeah, there was something coming out of the soil. Basically, the soil fixed carbon dioxide, took it out of the air. Actually, it was not nutrient. It was, we gave it carbon dioxide, but laced with radioactive carbon to be able to detect where it went. And so you leave it, then you look at the soil, burn it up to release what it has fixed, and photosynthesis fixes the carbon dioxide. And there was some release. So obviously the soil took up something and released it. Very bizarre. And finally, this guy, very clever, was basically give carbon dioxide nutrients with carbon-14, again, radioactive in it to be able to trace it, and see what happens to the soil when you give it to it. And indeed, this is Patricia Stratt, who ran that experiment with Jill Levine. Very clever design. And lo and behold, what happens is when you feed the nutrients to the soil, you have a burp of carbon dioxide coming out. If you give it a second bunch of food, doesn't really, it doesn't explode as you would expect from life multiplying. So, however, if you sterilize the soil and run the same experiment, zap, zero. So whatever was happening gets destroyed, as you would expect for life, by high temperature, 170 degrees, what we use for a sterilization. So that's what we came up with, is what the hell is going on? And for many years, there was a lot of discussion about this, and we'll just come back to it later, but I'm going to zip through, because then we had meteorite from Mars. So this is 20 years later. We hadn't gone back to Mars, and suddenly we realized that we have samples of Mars in our labs, fallen from above and collected in, say, Antarctica for this one. And interesting, in the little veins crisscrossing this meteorite, which is old, 4.1 billion years, veins slightly younger, 3.9, in which water percolated and deposited carbon globules, in which a team believed they found microfossils of something that had once lived on Mars, and that's the team. And indeed, not only were some very interesting forms, but they're only shapes, and that's not any proof of anything. But they also found a chain of little magnetite crystals that look like those used by certain types of bacteria, magnetotactile bacteria. So, whoa. And then they also found, finally, organic molecules, which Viking had not found for many reasons. So all that seemed like it pointed towards micro life as fossils in Martian rock. But finally, the scientific community decided otherwise, that nothing held up to this being essentially and exclusively biological and could be explained by many other parameters. So it fizzled. But this was the second possibility that we had found life on Mars, and it fizzled. Then Opportunity, briefly, show you where that landed, found traces of liquid water in the past that had percolated through the soil, probably like in sapkas that you find here in Brazil or in North Africa. It was proof that water not only can flow at the surface, but can soak as a water table, go up and down, which would be a marvelous place for microbes to develop. And here are the little beads connected with the reactions, not of microbes, but of percolation of water in the ground. Then this is not a rock band, Phoenix and the perchlorates, so sounds nice. And that was the landing of a platform in the very far north, around 68 degrees, if I recall, where evidence of ice was found. Okay, there was no surprise. We already knew from above that there was a lot of ice stashed in there. But more importantly, sniffing the soil with a wet lab developed in France, the SAM laboratory, large amounts of perchlorate, Cl O4 minus, were found in the soil, and suddenly that explained the Viking results that had been in limbo for so many years. Complicated, as you can see. There's going to be a quiz at the end. Complicated, but basically cosmic radiation will cause in the soil the formation of perchlorate. Well, actually perchlorate forms before by just reaction of chlorine and oxygen in the atmosphere. But what cosmic radiation does, it breaks it down to oxygen. I simplified the graph. It's more complicated than that probably. But also into another form of chlorine compound, hypochlorite. So the oxygen released by cosmic radiation on the soil will give the oxygen. That will give the signal in this experiment. And the perchlorate, oops, come back. Thank you. The perchlorate turning into hypochlorite explains the reaction giving carbon dioxide in the soil at various degrees depending on temperature, mimicking what we found in Viking. So that put to rest this hope that we had found life on Mars. Now, interestingly, perchlorate is a thing of toxic, etc. But we do know that perchlorate, when it's not broken down and it exists in the soil, many types of bacteria on Earth are very happy with it and live in polychlorate-rich soils. So it's not a showstopper for life on Mars. Methane, and we'll zip through the methane. First detected from the ground with infrared astronomy. Very much discussed, but because that's one of the possible explanations for methane would be what we know on Earth is mostly it is life forms that turned it out as waste. But it's not the only way, obviously. You get methane, you get it a lot from reaction in the soil of groundwater with basalt or anything else called serpentinization or carbonation. Those are processes that have nothing to do with life that yield methane. So it doesn't mean it's life, but it's a possibility. And what is interesting is Curiosity sniffed methane at the surface in Gale Crater, and that not too many data points. It seems to be seasonally linked with a lot of summer outgassing, but very little, 0.2 to 0.4 parts per billion. Part per billion is 0.00001%, okay? Talking small. But we've had some occasional spikes, and those are extremely interesting. Methane does come out as burps from the surface several times. Curiosity found it 5 times now, and like we're increasing by magnitude of 10. We're really flying up there. And it was detected at the same time by the European Mars Express vehicle with its spectrometer, and it did find it at the same time as the rover was sniffing it. It was sniffed from above. So that's interesting because some people can say it's the instrument that's at fault, giving a false signal. But when you have the same signal from 2 different instruments on 2 different spacecrafts, okay, we know that there is methane burps on Mars. So here gives you the whole story. I'm going very fast because it's in the abstract. But basically this is what I was talking about, is the burps, with one in particular that was seen by both spacecrafts in 2013. And then just recently there was one in 2019, and I think there have been some since, but those are high values. And methane seems to come out and disappear very fast. And that's interesting because what we're measuring is not the top amount, because it decays so fast that when you measure it, it's already been going down. And so the burps are significant. Now, where do they come from? Okay, this is just, we also found with Curiosity all kinds of interesting organic molecules. I'll pass on that. But where does it come from? InSight landed with American probe with a French seismometer in it. Very interesting because, okay, landed here. Very interesting because it measured earthquakes on Mars, Marsquakes, I'm sorry, which were traced to some interesting volcanic regions, and Cerberus Fossae would be an interesting place to go to because it has a wonderful, very fresh ash deposit, which is probably like 50,000 years old, not a million, on that range, very active recently. So maybe the burping actually are their faults cracking up and letting methane. So it would be a tectonic-driven process. And the fact that it occurs maybe more in the spring and summer, that also could mean that tectonic activity, as measured by InSight, can be focused on seasons for reasons that are hard to understand. But anyway, to finish, we have, very recently figured out that we have a water-soaked crust, apparently from 11 to 20 kilometer depth. That's where, by reanalyzing all the quakes, we have a sounding of the crust, and the signal corresponds to about 10% or 20% water in the fractures and the cracks between 10 and 20 kilometers depth. That would be the haven where life right now would be. Kind of deep, but that's where I'd go. And to finish off, Perseverance on Mars, the Jezero crater, as you know, the big news is that Perseverance, landed here, has been going here and then here in July 2024 at the Bright Angel Formation. Beautiful rock. Beautiful layered rock with very interesting little, so this is gypsum, this is clay, gypsum on the other side, and all these spots, if you look at them closely, they have a core and they have a rim around it, and they have different chemical compositions. And the experts that wrote the paper on this figure out that the only way they can see for this type of reaction to occur in the minerals is life-driven. They tried to recreate it inorganically by equations of different reactions of minerals and did not get anything close to this. So, until proven otherwise, it appears to be an interesting possibility, clue of ancient life on Mars. So, and that's the core that's been done. Obviously, you'd like to bring it back. Be best to be there. Here's a very nice portrait by Georges de la Tour of two geologists at work. No, just a photo. In a flash Mars mission with Robert Zubrin finding a stromatolite straight off the bat, walking out of the habitat. And it's just interesting to show the difference of speed between a human crew and robots. Using them both, this is an interesting, that's a microprobe to study the composition of minerals, an electronic microprobe. And this is Kayla Baron, US astronaut, doing an experiment of studying a rock chip in space, and also can be piloted by someone on Earth who's a specialist. And so they did in the ISS just recently a comparison of a spectra, and you have two lines, the red and the black, one done by Katie at NASA, the other one done by the astronaut on board, same thing. So we have some good instrumentation, and when you have the experts behind on Earth, they don't even need to travel to Mars, though it would be nice for them to be there. Voila, voila, okay. Those are just choices, just to show either we want to go a place we've already gone with robots, which helps us know where we want to go to look for life forms, or find another beautiful place. I like Pole Crater. A nice article was written about it with François Costard, actually, a French geologist on the team, where we have a great crater that splashed into ice deposits at the bottom of an ocean. Wonderful place. But anyway, just a choice. So there we go. So any questions? Very fast and no answers. But just to give a kind of synthesis of where we're at with seeking life. Obviously, a lot of disillusions, false hopes, a lot of leads, and some firm right now. And that's an interesting turning point, especially if you want to promote manned missions to Mars. We have, until proven otherwise, a very interesting clue that we did have life forms in those rocks. And as far as I'm concerned, if there were life forms, they're still there living, except in a different place. That's the positive attitude, the optimistic attitude. Obviously, the search for life is not subjective. I mean, it's not objective. Everybody has a point of view when they go into it. Mine has been 50-50, normand, as we say in French. Oui, non. But I like what this team has discovered with these rinds and cores of these minerals. That's very suggestive, but not conclusive. Voila.
We have time for questions.
So I ran through at full speed because the interesting debate, interesting maybe to know who is interesting psychologically, who is in favor of thinking there is life on Mars and who thinks the odds are rather that there is not life on Mars. Life on Mars, who's a follower of life on Mars as just a personal choice based on what they've seen so far, and who thinks that non-life on Mars so far is the best the best explanation so far for many reasons. So that's interesting. About I'd say 2/3 or more biased towards life, and 1/3 is like more biased towards non-life. at the present. That's an interesting mix. I like it.
What is your percentage of probability for you? Is it 100%? Is it 95%?
For me, it's 100% that there is still life on Mars, that there was and there is, and it's just a personal choice of mine. I would be, let's say, I would be very disappointed if there were not life on Mars. That's just because the conditions were the same. We were playing ping pong, throwing rocks at each other during the beginning of the solar system. So if there was life that started on the Earth, it got splashed to Mars at some point. So I would be very surprised that it didn't take a foothold, even if it was terrestrial, or if it was totally Martian from the beginning. But that's already two choices to get life on Mars. So I'm pretty optimistic that it got there. And if it got there, knowing that life really doesn't like to die by evolution, I would be surprised if we're not still there. Michel.
You already know that there is no way to tell that there is no life on Mars.
Exactly, exactly. You cannot. It's just like
Science.
exactly. It's the famous all swans are white. No, you cannot say that. There's always a possibility that one day you will find a black swan. You'd have to go and find every swan in the universe before you can say that. But the inverse, as you say, right, is you have to. It's very difficult to prove that life doesn't exist. However, proving that life exists, as soon as you found it, you found it. So it's easier that way. Yeah?
I mean, to counter that, of course, there's the argument of Russell's teapot, but that's another story. I don't want to get too much into this. My question would be more in the direction, assuming that there was life on Mars, how would we see it and where would we be looking? I mean, again...
Yeah, that's... you have an idea about that, Michel? I would say you have to go down deep. Now, obviously not the top surface because of cosmic rays and UV and all that. That's kind of toxic because you get a lot of molecules being broken down and making aggressive oxygen, superoxides, etc., superoxygen. I would think if you could find something, brines, like we have some, of course, we know under the polar caps that are not too deep, or because the crust is soaked with water, liquid water, starting around 10 kilometers, if those results are confirmed. This is just one theory, but so far, that's the interpretation. Digging down 10 kilometers, we've done it on Earth in two places, one in China and one in Russia. It's a lot of work. So if we could find a pod of liquid water, just fractures. You don't need much because as you go down in the surface, the pressure is going to increase if it's an open system with the atmosphere. So if you can find cracks that go down another 3 or 4 kilometers below datum, yeah, you're gaining that pressure, which gives you more temperature bracket for liquid water to exist, and you get the heat because you get the geothermal, aerothermal gradient going down. You just have to find that pocket that's close enough to the surface to be accessible. That's going to be the thing.
If I'm not mistaken, there was a Soviet probe which was in orbit in the 60s around Mars and should not have done it, but it crashed.
Uh-huh.
It was unsterilized.
Oh, yes. Absolutely.
Is there a risk that if we find life on Mars, it comes from Earth?
Yes, we have that problem. Mars 2, Mars 3 crashed. We also crashed, Climate Observer crashed, and we also crashed...
Eagle too.
Right, we crashed a lot of things on Mars, American and Russian.
British.
And British. Not to say European. And European with Schiaparelli. Absolutely. So we crashed a lot of things on Mars. Now, the Russians, certainly not very well sterilized. A little dash of alcohol, and hey, let's go. The Americans spent a lot of money. That's why Viking was so expensive. Everything had to be sterilized before it went. All the electronics had to go into a heat cooker And so that's why everything skyrocketed in prices. Indeed, the question is, once you find life on Mars, is it contamination by a crew or one of our robots? Is it brought to Mars by a meteorite from Earth? Or has it begun on Mars? Or the Arrhenius exolife panspermia? Or has it even come from elsewhere? So you almost have 4 different branches for explaining a positive signal that you get on Mars, life-wise. But indeed, it's going to be very interesting if we do find life, fossil or extant. Where does it stand with its similarities, ARN, DNA, whatever, with life, with terrestrial life? And that's going to be the next question.
There has been a separate evolution.
Separate evolution, hopefully. Hopefully we will find, yes, because even if it were terrestrial to start off with, obviously it will have evolved in a completely different direction. Yes, but we might find clues that it came from the same stem mother cells.
Thank you. I think we have to start now.
Thank you.